In this video, we're going to take a look at performing indicated operations with our trigonometric functions, and also we're going to delve into verifying our trigonometric identities. All right, so in the last section, we took a look at we did a review of some of our fundamental trigonometric identities and added the negative angle identities. And then we went through a little process where we manipulated our fundamental identities into alternative equivalent forms. But one of the things I do want to take a look at is one other type of manipulation, because sometimes this is really useful when we're doing trigonometric verification. So for my Pythagorean identities, I notice that each one of them has a value of 1 in them, and if I solve for 1, I get 1 equals sine squared plus cosine squared theta. Here I get, if I solve for 1, secant squared theta minus tangent squared theta, and in this one I get 1 equals cosecant squared theta minus cotangent squared theta. So sometimes when we're proving and we end up with a number 1 in our proof, we can replace that number 1 with anything that's equivalent to the number 1. And here are some alternative equivalent forms where I can see 1 equals any of these 3 different expressions. All right, so let's get started on the examples for this. And before we get started, I want to just point out that I did ask you to read 2 pages in your textbook and then to go through the very first 4 examples. We will only be doing verification of our identities by working one side. So make sure that you read those first 4 examples. Skip example number 5 because we're not going to work both sides of our equations. We're only working one side. So for all of these examples, I'd like you to keep your book open to page 197 because they have really nice hints for verifying identities. And I'm going to be calling out some of those hints as we go through some of these problems. So it says for number 2, we're gonna work through a whole bunch of examples. Again, you guys can come and go. When you feel like you're confident to start your homework, go ahead and start it. But I'm going to be doing a lot of examples from each of the sections here. So number 2 through number 11, it does say perform each indicated operation and simplify the result so that there are no quotients. So we're going to take a look at this one. And one of the hints that's found on page 197 is to convert everything into sine and cosine, because I don't necessarily have any identities that tell me how secant and cosecant relate. So I am going to go ahead and convert to sine and cosine. So I get this when I convert to sine and cosine. All right, so now how do I simplify something like this? Well, I know that when I divide by a fraction, that's like multiplying by its reciprocal. So I'm dividing by this fraction, so I'm going to multiply by its reciprocal. Again, here I'm dividing by this fraction, so I'm going to multiply by the reciprocal. Over 1. Sorry, I got lost in my thought there. So when I do that, I'm going to combine these. When I multiply, I get sine of x over cosine of x plus cosine of x over sine of x. All right, so the indicated operation is addition. I haven't really added yet, so I need to find a common denominator. So I'm going to multiply. My denominator is going to be cosine of x, sine of x, right? Because that's what's in my denominator here. So I'm going to multiply my very first fraction by the sine of x over the sine of x. And I need a cosine in this denominator, so I'm going to multiply by cosine of x over cosine of x. So this is just simple algebra that we did back in chapter 6. So I end up with sine squared of x over cosine x sine x plus cosine squared x over cosine x sine x. Now they have a common denominator, so I can add these, combine them into one fraction. And one of my identities says that sine squared x plus cosine x equals 1. So now when I simplify, I get this. But I'm not allowed to have any quotients in my answer. So I'm going to split this up into this. And I hope everybody agrees that I can do that, because when I multiply fractions, I'm just multiplying across. So what's the reciprocal of cosine? Well, that is secant of x. What's the reciprocal of sine? Well, that is cosecant of x. And that's going to be my final answer. So there was a lot of little manipulations I did to get this final answer. All right, number 11. The indicated operation here is subtraction. So I can't really subtract unless I have a common denominator. So I'm going to take this very first expression, my common denominator, my LCD, is going to be 1 plus cosine of x times 1 minus cosine of x. So I'm going to take my first expression, 1 over 1 plus cosine of x. I'm going to multiply it by 1 minus cosine of x over 1 minus cosine of x. I'm going to take my second expression, 1 minus cosine of x, and multiply it by 1 plus cosine of x over 1 plus cosine of x. And when I do that, I get 1 minus the cosine of x over 1 plus cosine of x, 1 minus cosine of x. Minus, I get 1 plus cosine of x. And I'm going to put these in parentheses. 1 plus cosine of x times 1 minus cosine of x. Now I have a nice common denominator, so I can actually do my subtraction. So I'm going to combine it into one fraction first. All right, so now I'm going to distribute this negative sign, and I get 1 minus the cosine of x minus 1 minus the cosine of x. And I'm actually going to multiply out this denominator here. Okay, so if you remember, a plus b times a minus b equals a squared minus b squared. That's back from chapter 5. So that's what we have here. A is 1 and b is cosine of x. So if I square 1, I get 1. If I square cosine of x, I get cosine of x squared. So when I reduce this, my 1's are going to reduce out to 0. Minus cosine of x minus cosine of x is minus 2 cosine of x. But I also know that 1 minus cosine of x is one of those alternative forms of my Pythagorean identity that equals sine squared x. But now I'm not allowed to leave quotients, so I'm going to split my sine squared of x up into sine of x times sine of x. And I know that this part is cotangent, and I know that 1 over sine of x is cosecant. So I get negative 2 cosecant of x, cotangent of x for the answer to number 11. Okay. So now number 14 is a new section. The instructions for number 14, it says factor each trigonometric expression. So factoring should be really easy. Okay, so if I said a squared minus 1, this is the difference of squares, right? Or let's use x in this example. This is the difference of squares, and it factors into x plus 1, x minus 1. What if x was the secant? Okay, if x was the secant, this is the difference of squares. So I know this is going to be secant of theta plus 1 times secant of theta minus 1. Okay, so how about in this example? Our next example. How can I factor this? Again, it's the difference of squares. If A is tangent x plus cotangent x, and B is tangent x minus cotangent of x, I know that a squared minus b squared simplifies into a plus b and a minus b when I factor it. So if A is this expression and B is that expression, I'm just going to go ahead and substitute those expressions in. I get the tangent of x plus the cotangent of x plus the tangent of x minus the cotangent of x. And now for the subtraction, I get the tangent of x plus the cotangent of x minus the tangent of x minus the cotangent of x. All right, so let's go ahead and simplify that. So we get the tangent of x plus the cotangent of x plus the tangent of x minus the cotangent of x. Then we get the tangent of x plus the cotangent of x. And we're going to distribute that minus the tangent of x plus the cotangent of x. And here our cotangents are going to reduce out. So tangent of x plus tangent of x is 2 tangent of x. And we're going to multiply that by, okay, your tangents reduce out. I'm going to multiply that by 2 cotangent of x. And we eventually get 4 tangent of x cotangent of x when we factor this expression. All right, we'll have time for this one last one, and then I'll start another video. All right, so if it's difficult to look at our trigonometric functions, we can always use u substitution. Let's say u equals the tangent of beta, and we'll just rewrite this expression as 4u squared plus u minus 3. So how do we factor something like that? Do we have factors of negative 12? Remember, we multiply a and c that add to b, which is 1. We do. 4 and negative 3 work. So I can say 4u squared plus 4u minus 3u minus 3. And now I'm going to factor by grouping by taking a 4u out of the first two terms. And I'll take a minus 3 out of the last two terms. And when I'm done, I get this. And now I can just go ahead and substitute tangent of beta back into this expression to get a factored form of 4 tangent of beta minus 3 tangent of beta plus 1. All right, so I'm going to start up another video to finish the examples.